we will proceed towards our next topic or our next point, which is nothing but architectures. So, as basically, we also have discussed about various types of architectures, that is Harvard and von Neumann architectures. Okay, and in short, we also discussed about Harvard and von Neumann. What Harvard means, what von Neumann means. Okay, so here we will go in detail and have uh, in detail or complete understanding. We will try to understand how Harvard architecture will help us for development of various advanced systems as well as embedded systems. Okay, or how Harvard architecture is different from von Neumann architecture. So, if you see the history, Mark II computer was finished at Harvard University in 1947. It wasn't so modern as the computer from von Neumann team, but it introduced a slightly different architecture. Memory for data was separate from the memory for address. Okay, okay, or code. So if you look here, I have you can see a typical block diagram representing Harvard as well as Harvard architecture. Here we have a central CPU, okay, and our central CPU is connected with code ROM as well as data memory. Or we have our central CPU has separate address bus for data as well as separate address bus for code. Okay, since both memories are separate, our CPU is connected with separate data bus. Okay, so to carry data to and fro, to and from, sorry, our data memory to microcontroller as well as microcontroller to data memory. So this is a typical example for in the case of peak, but you can use just a minute. Someone is, I think, joining. Okay, so uh, as microcontroller will require data memory to store data during runtime, we will use, or microcontroller will use this data memory to store data bytes during execution of program. For example, during an execution of some arithmetical or addition program, you need to, or one need to save result of operation. Okay, so to store that temporary result, we must have to, or we have a data. So this data can be stored on this data memory. Okay, here code memory is nothing but it holds the hex codes of our program. Hex codes. What do you mean by hex codes? What do you mean by hex codes? Hello. हेक्स
0 to
कोड्स कशाला म्हणायचं?
8 बायनरी मध्ये 0 to 8 मध्ये बायनरी नंतर मग ABCD फॉर्म मध्ये.
ओके, हेक्स कोड्स, ठीक आहे. Hex codes are basically hexadecimal number systems code, and here in our microcontroller we are transferring our instructions to machine level language, and machine follows only hexadecimal number system. Actually it follows binary number systems, but for our human introversion we use it in the hexadecimal form. Okay, machine only understand 1 and 0. It does not understand 0f, 01, 04, 40. It doesn't understand anything. It only understand either 0 or 1. But for our sake of simplicity, we have converted this machine language into, or not converted, we have just decoded this machine level language to human understandable codes or format hexadecimal system. And actually human understandable language is not machine language. Actually we used to write instruction like move lw. In peak microcontroller we used to write this instruction move lw. So move lw is not understandable or is not understood by machine. Okay, so this is a human understandable format, and the respective code of this move lw is nothing but machine level language. And the simplified version of this, for example, 00112468, sorry, this is I have written 0, so my 4 and 3, 34, isn't it? So 34h is the value or decoded value for human sake of understanding. Okay, human language is move lw, machine language is 00011100. But for understanding of us, we have, or simplicity, sake of simplicity, we have converted, not converted, we have formed or decoded this into hexadecimal number system. So those codes are stored on code memory. Those codes are nothing but our actual program opcodes. Okay, so this is the basic of Harvard architecture. Then what are the advantages having Harvard architecture? So first and important advantage is since it has two separate memories, it allows parallel access to data as well as instructions. Okay, so I will again go in previous slides. Okay, so since we have separate memory for data as well as code, we can do both operations simultaneously. Okay, are you getting this point? Since we have two separate memories, I can or not I, microcontroller can save data on data memory. At same time, it can fetch instruction from code memory. Okay, so fetch operation as well as data storing operation, or in peak microcontrollers language, this processing is nothing but write back. What is its name? Write back. It will take a write. I think we have studied or came across this in third year BSc, BACK, BACK, write back. Okay. Uh, Reading codes from memory is this process is nothing but fetch operation. Writing data on memory is this processing is nothing but write back operations. I know all of you know the process, exact process, but the standard names of those processes are different. So reading codes from memory, this process is called as fetch, FETCH, and writing data on data memory, this process is nothing but write back operation. So what is advantage of having a Harvard architecture? Since we have two different memories, we can save or we can write back or as data sorry, as well as fetch instructions from both memories simultaneously. Okay. Then development of control unit is expensive and needs more time. Actually, this is not going to be advantage. Actually, this should be the disadvantage. So we will cover this point. Then data and instructions are accessed the same way. As we have separate memories, yes, we are accessing both data and instructions parallelly, but accessing of both data as well as instructions can be in same way. Same way means we can use same instruction to perform same operation. For example, if you remember in 885 microprocessor, we have move instructions as well as LHLD, then LXIH. Okay, so data transfer instructions between registers as well as data transfer instructions related to memory operations. Both different types both same types of operation, but instruction or accessing format was different. But here, due to this point, we are having this advantage that we can access both data from memory as well as code at using same instructions. Okay, if this case appears, then another one advantage is both memories can have, or both memories can be different size as well as different cell size. So what do you mean by cell size? What do you mean by cell size?
internal memory.
See, cell size is nothing but your width of memory. Okay, since we are having different memories, so just assume that we have a only single memory for data and code. Okay, so let us assume a memory structure which is having only one memory, and this can be used as well as code as well as data, like one human architecture. So what will be happen in for both, since memory is same, the cell size will be same throughout code as well as data. But in Harvard architecture case, since we are having two different memories, memory sizes or cell size are can be different as per our requirement. This is important thing. The cell size is different. That is not advantage. Advantage is that as per our requirement, we can have our cell sizes. Okay. So uh, then what are the disadvantages of memory? So first, that we have already skipped, development of control unit is expensive and needs more time. Yes, since more features or more memory we have added in our system, so to control this memory operation, we need to design unit that will help us to operate simultaneously on both memories. So its design is going to be a complex, as well as, since it is complex, it is going to expensive thing, and as well as expensive in the in point of view of cost, as well as in point of view of time, because since it is expensive, it will take more time for designing. Then free data memory can't be used for instructions and vice versa. This is a very important point to be noted. So what this advantage is, suppose uh, in any application I am using only one third or one fourth part of this data memory. Okay, for example, let us assume that this part I'm only using in any application. So this remaining part is free. Okay, understood? Since I will be using only one fourth part of my memory, remaining part is going to be free. It is not going to be used anywhere. But uh, in same application, if my program size is, or my instructions, whatever instructions I will be using, let us say program, so my program size is going to greater than this memory, then remaining program codes cannot be stored on data memory. Okay, you are getting this point. If for example this is a 2 MB memory space, and suppose I have developed a program which is consuming 2.5 MB. Okay, so this memory will only store 2 MB. To store rest of zero point 0.5 MB or 512 uh, bytes, kilobytes, I need to use separate memory. Since I have this another memory, I cannot store those bytes here. I must have to interface external memory to store these remaining bytes. You are getting this point? Hello, clear? So though my data memory is free, I cannot use this memory to store instructions, and vice versa. For example, my code is just 2 or 3 lines code. Okay, 2 3 lines code means just 2 3 bytes of code, and my memory is having capacity 2 megabytes, and but those 2 3 lines codes are taking continuous, for example, reading continuous ambient temperature. Then to store continuous ambient temperature, I will require more memory. So if this memory size overflows, then it microprocessor or microcontroller cannot store data on free memory space of code memory. Okay, so for data purpose, I need to add external data memory. Okay, I think this point has been cleared. So what is its disadvantages? Free data memory
सर आवाज क्लिअर येत
cannot
नाहीये.
be used. Okay, disconnect होतोय का?
हो हो सर.
Hello. Continue. So हा
सर नाही येत नीट आवाज कट होतोय.
कळत होते. कुठून कट झाला आवाज? आता कंटिन्यू.
सर
हॅलो, आता येतो क्लिअर?
हो सर, येतोय.
होय तर.
ओके. Just a minute, I will share my screen. So, I was discussing disadvantage of memory. So, what was the disadvantage? Free data memory cannot be used for instruction and vice versa. So, what do you mean by free data memory? Suppose, uh, since I am having different memories for my operation, and for example, I am having code of 2 or 3 lines code. Okay, 2 3 lines code I have generated. For example, the code I have written for reading continuous temperature from temperature sensor. So this code will take some bytes of memory, and remaining memory will be left unused. Since I have written only code of, just assume that we have written code of 1 kilobyte. Okay, so rest of bytes are unused, and in data memory, what we are using doing, we are continuously saving. For example, here we will be having a temperature sensor, so I will be having data from temperature sensor, and I am saving the current temperature on data memory. So after some time, this memory will be fulfilled or filled completely after saving continuous temperature sensors data. So after getting full, this microcontroller cannot save next temperature values to unused bits of code memory. Okay, since your data memory is full, it will cannot go to code memory and store your temperature. This memory will left as it is. To overcome this problem, you need to interface external memory for storing of data. Okay, or suppose uh, there might be a other case that you are not using data memory in your application. For example, you are writing a program to toggle LED status. So in toggling of LEDs, we will not require any data memory space. Okay, but let us assume that there are various steps, and those steps have completely filled or used this code memory. Okay, so suppose your program size now becomes 2.5 MB. Okay, so and our original size of memory is maximum capacity is 2 MB. So rest of zero point 0.5 MB, where I need to store or where microcontroller will store. Since or though this data memory is completely free, microcontroller will not store this code memory on data. Sorry, this code zero point 0.5 MBs of code on free data memory. We to save this memory again. In this case also, we need to use extra external memory. Okay, have you got this point? Free. Hello,
Yes, sir.
hello. Okay, so and don't uh, confuse here. Free data memory, it can be any memory. So I can say free data memory cannot be used for instructions, or free instructions or code memory cannot be used for data. Clear this point?
Yes,
The
sir.
next, production of computer with 2 bus is more expensive and it will need more time. So this point is same point as we have already discussed. So I think you have cleared about Harvard architecture. uh, is there any doubt regarding this Harvard architecture? how Harvard architecture is, and what are the advantages as well as disadvantages in Harvard architecture. Hello, hello, am I audible?
Yes, sir.
Okay, so we will see von Neumann architecture. So, what von Neumann architecture is? So, history of von Neumann is between 1945 and 1951. John von Neumann set down the structure of structure or layout, interactions, cooperation, realization, implementation, and functionality activity for full instructions mechanism or instructions. Means, in simple words, we can say John von Neumann have defined how instructions are, or how instructions are stored on our CPU, how organization of memories should be there in CPU. So if you look here, the block diagram or pictorial representations of memory, then you will realize that yes, we are having separate code memory and data memory. Okay, but the address bus and data bus for both is common. Okay, in some cases, it can be represented that the memories can be same. Same. Why? Because as our code as well as data sections or accession is same. So since whatever advantages and disadvantages we have studied up till now in Harvard section, those advantages and disadvantages can be overcome. Can be also looked or compared with von Neumann architecture. So we will uh, go to von Neumann architecture, what it takes to form von Neumann architecture. A memory arithmetical logical unit, or it can control unit. It can take control unit, inputs and output devices. All parts of computer are connected together by bus. So memory devices are controlled by CPU. So I will be having any memory device. It can be controlled by CPU. So data can pass through a bus in half duplex mode and to and from CPU. Okay. Uh, half duplex mode. Full duplex means simultaneously I can do anything. Data communication in both direction. But half duplex means at a time only one. Memory holds both program and data. Memory holds both. This is important specification or characterization of von Neumann. It can hold both program as well as data. This is known as stored program concept. Okay, so memory is addressed linearly. That is, there is single sequential numeric addresses for each and every memory location. And actually in both cases, memory is addressed linearly. So von Neumann architecture, as previously I have discussed, von Neumann has set down some of rules or structure. So in layout, this John von Neumann, defined that memory should be addressed linearly. What linearly means? Starting address of memory if 000, the next address should be 0001. The next address should be 002, 3, 4. This is nothing but linear memory addressing. And this concept is also, as it is taken in Harvard architecture also. Even all memories or all devices follow same structure, addressing structure. Then there is a single sequential numerical address for each and every memory location. Yes, for first memory location we have single memory location, or sorry, for first memory location we have separate and single address, that is 00. For second memory address we have memory location, we have address 01, which is this address is unique, this address is unique, and the relation between these two is uh, those are organized in linear fashion. So we have single as well as sequential numeric addresses. Numeric means those whatever numbers we are referring here, those are nothing but numeric addresses. And this is very important characteristic of any memory device, that all addresses, memory locations or addresses are single. Single means unique. We do not have same memory location in other place of anywhere in memory. In complete memory, we will be having only one such a memory location. Okay. Then memory is addressed by location number without regard to data contained within. सरळ याचा जर मराठीत तुम्हाला जर अर्थ सांगायचा झाला, तर त्या मेमरीमध्ये काय स्टोअर केलेलं आहे यापेक्षा त्या मेमरीच्या ऍड्रेसवरून, सपोज हा जर ऍड्रेस असेल तर या ऍड्रेसवरूनच त्या मेमरीला काय केलं जातं, ऍक्सेस केलं जातं किंवा कॉल केलं जातं. यात काहीही डेटा असो, अल्फाबेटिक असो, न्यूमरिक असो ऑर एनिथिंग. So it can be addressed, memory is addressed with, or memory is addressed only with its linear address regardless of its data. Okay. Then memory is split into small cells with same size, and actually we refer those cells as bit. Okay. And our regular data memory is split into 8 such a small cells of same size. That is, each device each cell will be holding only one bit. Then their ordinal numbers are called address numbers. So for example, I will take first memory location 000. Okay. So this 000 memory location will be split into, sorry. So this 000 memory location will be split into 8 small cells of same size. 1, 2, 3, 4, 5, 6, 7, 8. And their ordinal numbers are called address number. So this number is called as address number of, this is the address of memory location. Okay. And this is ordinal address number. Okay. And so on. Last will be 7. So we already know about what is this. This is our memory address or location number. Okay. So this is our location number and this is our address number, or these are our address numbers. So uh, don't confuse in location number or address number. Clear? These points related to memory clear?
Yes.
And all those points or all those characteristics are set by John von Neumann. Okay. Then what are the advantages as well as disadvantages of having von Neumann type of architecture? So what will be the advantages and disadvantage? Hmm? what will be the advantages as well and disadvantages if you compare with our Harvard architecture? Then
सर हार्डवेअर आर्किटेक्चर आहे ना सिम्पल आहे व्हॉल्युमनपेक्षा.
okay, but if you see, we have made a point in Harvard that it is, in design perspective, it is complex. Why? Because it will we will require two
सिम्पल.
control units to control both separate unit memories, isn't it?
येस.
Okay, so we will look one by one. Control unit gets data and instruction in the same way from one memory. So since both data memory as well as code memory, okay, so it control unit gets data and instruction in same way. Means if I want to read instruction from memory, I need to follow same structure, or same process, or for data it is also will follow same process. So it simplifies design and development of control unit. Since both memories are uh, to be same, or data and its address bus is going to be same, so it simplifies design and development of CPU. In case of Harvard, design is bit complex, so it will take more time as well as cost in its design. Then data from memory and from devices are accessed in same way. Uh, so memory and devices can be accessed in same way. So memory organization is in the hands of programmers. So since only one memory is used here, so programmers are responsible. Programmers means we. Since we are writing program, we are responsible to store program on memory, or sorry, code on exact memory location, or data on exact memory location. So there might be possibility that someone can write uh, code section, then data section, code section, data section. And as we have studied characteristics of memory, memory is accessed linearly. So if such a thing happen, then it is going to lead a certain catastrophe. But for right now, if you see the advantage that we can store any, at any point of view, or any at any section of memory, we can store code or data. There is no limitation like in Harvard, that we have to use only code section to store code, and data section for data. We cannot store data into code section or code into data section. Okay, so in one human, you can store any part of your code or data in any part of memory. So yes, for programmers perspective it is simple, but if you make mistake in doing this, then it is going to lead a certain catastrophe. Then serial instruction processing does not allow parallel execution of program. So what do you mean by serial instruction processing? All instructions are processed one by one. Okay, which means serial instruction processing. I will microcontroller will process first instruction. After completion of the first instruction's execution, microcontroller will process second instruction. So it will process serial instruction. Okay. So since all instructions are processed one by one, there is not parallelism is not possible in von Neumann architecture. Okay, von Neumann instruction processing is also serial way, but for storage of data, we have separate address and data bus. So while processing one instruction, I can process data also on other address and data bus. So parallel executions are simulated later by operating systems. If you want to do this, then you must have to uh, use or take advantage from operating system. Then one bus is bottleneck. So only one information can be accessed at the same time. The point I have discussed already is one bus bottleneck. What do you mean by bottleneck? What is bottleneck? Uh, I think in first semester we have seen this bottleneck, one Newman bottleneck. Hello.
सर एका वेळेस एकच इन्स्ट्रक्शन फॉलो होते.
Okay. At a time, only one, not instruction, only one operation. This operation can be instruction fetch or operation can be data write back. Operation can be either one. Okay. But since at a time only one operation is going to process, the other operation which is in queue, it must be or it needs to be wait until first operation has been or first operation is processed. ओके. म्हणजे सपोज ऍट अ टाइम जर दोन ऑपरेशन जर आली एकाच वेळी मी डेटा पण राईट करणार आहे आणि पुढची इन्स्ट्रक्शन रीड पण करणार आहे, तर मला एक ऑपरेशन होईपर्यंत दुसरं ऑपरेशनला काय करावं लागेल, होल्ड करून ठेवावं लागेल. इनफॅक्ट होल्ड करावंच लागेल, त्याशिवाय यूज करू शकत नाही, कारण माझ्याकडे फक्त वन वे आहे. जस्ट टेक एन एक्झाम्पल ऑफ ट्रॅफिक लेन्स. इफ यू हॅव ओनली वन लेन फॉर ट्रॅफिक, okay, and like in घाट सेक्शन्स, आपल्या घाटाच्या रस्त्यामध्ये तुम्ही बघितलं असेल, फक्त एक जर सिंगल वे असेल तर एका व्हेकलला थोड्या वेळासाठी थांबून राहावं लागतं जोपर्यंत दुसरं व्हेकल पास होत नाही तोपर्यंत. बरोबर. सेम केस हिअर ऑल्सो, इफ सम ऑपरेशन is taking or executing, then another operation must be need to be wait. So it is nothing but bottleneck. Then instructions stored in same memory as the data can be accidentally rewritten by error in program. So that point I have discussed. uh, Suppose I have written uh, this memory organization is in hands of programmers. So I have written memory, instruction, then code, and due to some negligence or any accidental data fetch or data write operation, it will going to make certain catastrophic in our program. For example, instead of instruction, I have written some data after instruction, okay, or after code. Then our program counter will continuously read each and every instruction. After first instruction, this will read next instruction. But here, by mistakenly, I have written some other data. Okay, so microcontroller will assume that data as instruction, and it will try to decode this instruction. Okay, and since it is simple binary number, if this binary number matches with whatever opcodes we have, then microcontroller will perform that operation. So this is going to be a serious problem. So instructions stored in same memory as the data can be accidentally rewritten by an error in program. So it is a disadvantage of having same memory. Okay, so is there any doubt regarding to von Neumann as well as Harvard architecture? Hello.
No, sir.
Okay, so I think uh, you are now clear about the major difference between Harvard as well as von Neumann architecture. So we will have another type of architecture, which is software related architecture, and those are nothing but RISC as well as CISC. But I will okay, we are having 10 minutes, so we will just see one type. But before going or moving further, are you clear about von Neumann and Harvard? Or if you have any doubts regarding, we can I can solve those doubts. हॅलो. अरे मी काहीतरी विचारतोय, रिप्लाय दिलेला नाही का अजून कुणीच?
Sir, no doubt.
तुझा
No
एकट्याचं
doubt.
ठीक आहे रे, बाकीचे काय झोपलेत का? हॅलो. आवाज येतोय का नाही कुणाला?
Sir, येतो.
मला असं वाटतंय फक्त एकट्याला साबळेलाच मी एकट्याला शिकवतोय काय? होय साबळे. ओके. अज्युम करतो तुम्हाला समजलेलं असेल. देन कॉम्प्लेक्स इन्स्ट्रक्शन सेट कम्प्युटर. Again, this point also we have considered or studying in computer organization. So CISC is nothing but complex instruction set computers. So CISC processor has complex instructions that take multiple clocks for execution. Multiple clock means some instructions will take one clock pulse, while some instructions will take two clock pulse. Some may take three, some may take four, some may take five. Multiple clock cycles. Okay. So average clock cycles per instructions can be 2 to 15. Okay. So those vast number of clock cycles, those processor will take. So those are very complex in the form of execution. So the key characteristic of complex instruction set computer is the instructions will take multiple clocks for execution. Then the instruction set has variety of different instructions that can be used for complex operations. For example, variety of instructions means the instructions which is taking one clock cycle. This can be a 1 byte of instructions, or this can be a instruction, simple instruction. The instruction which is taking multiple clock cycles, this instruction is nothing but complex type of instructions. So for example, we can have an NOP instruction, as well as we can have DJNZ type of instruction. So both instructions, but NOP will take one instruction cycle, while DJNZ will take 3 or 4 instruction cycles. So what it does, it decoding or increases decoding of instruction is complex. It makes the decoding of instruction complex. Since I do not know after how much of time or after how much time I will be having exact meaning of instruction. Okay, let us assume that, or let us have example of today's lecture. Let us consider. All of you know that this lecture is going to end at 11 o'clock. Okay, so you are prepared for sitting up to 11 o'clock. But let us assume that if you don't know when whenever this lecture is going to end, then you may not be prepared for or if I extend this lecture up to 12 or beyond 12. Okay, you may not having your food, or you may having your separate plannings, so it is going to complex make your things complex. So decoding makes complex because microcontroller is not or your processor will not be knowing for which instruction how much time it will require. Okay, so CISC has many different addressing modes as compared or with considering various instructions, as there are multiple instructions, so it is again having various addressing modes. So uh, those can be used to represent higher level programming language statements more efficiently. Okay, so it has memory unit to implement complex instruction. As in previous sections we have studied a memory unit which used for decoding of instructions, which is used for storing of instructions, and control unit which is used to access memory as well as decoding purposes. The performance is optimized with more focus on hardware, only has single register set. What do you mean by more focus on hardware? Since all instructions are in complex format, instruction decoding, not instructions complex format, but since variety of instructions, decoding is complex. So all those complex things are handled at hardware level. So you might be having various instructions, but those instructions are decoded by using more features or adding more features in hardware. Okay, so more focus or more emphasis is given in hardware in this CISC architecture, and has only single register set. Single register set means only limited number of registers to store your data. Okay, then it requires external memories for calculation. Why? Because we have limited number of registers. So for having extra data space, we must to use or we must have to use external memory. They are normally not pipelined or less pipelined. Since instructions are going to complex, complex means multiple clock cycles, so we cannot use pipelines. Why? Because we do not know which instruction will come at what time. Okay, because each program is having separate instructions, and those instructions again in separate sequences. So we do not know which instructions will come at what time. So we cannot organize them in pipeline fashion, or we cannot have a pipeline of instructions, because in pipelining the instruction size is same, then and then it is going to be an efficient pipeline. If all instructions are taking similar time, say, or same time, then it is going to be a very efficient pipeline. And then it has a micro programming unit which makes it complex again. The problem is due to microprogramming unit. Then execution time is very high. Code expansion is not a problem. Again, execution time, as instructions times are taking more time, we are having more more time for execution. Then code expansion is not problem. There is not a problem associated with code expansion. Why? Because uh, since our instructions of having various instruction sizes or execution sizes, it is I can use a complex instruction to eliminate or to remove multiple lines of program. For example, if I can have a decrement instruction, I can have compare instruction, and I can have jump instruction. But in sys format, I can have only one instruction instead of these three instructions. So expansion is not problem because I can have various instruction, various uh, complex instructions which can be used for minimizing of our code. Then CISC architectures use sorry CISC architectures used in low-end applications such as security system or home automation. Right now, this approach is its approach is changing. So, but we can say those systems can be used in low-end applications since program is not going to be complex. Low-end, since it is low-end application, our system will do in efficient manner. So there are various examples of sys processors like System 360, VX, PDP-11, Motorola, 68 family, AMD, and Intel x86 processors. Okay, those are following CISC architectures, and since those are having CISC architecture, we know that Intel or Intel's x86 microprocessor, we need to have separate memory. The programming or hardware point of view, hardware is more focused. Program is a little bit complex thing. Okay, so this is about CISC architecture. Then we will study risk in next lecture. Is there any problem about CISC? Then you can discuss here or later on. If you have problem, then we can discuss. Hello. Is there any doubt?
No, sir.
Okay.
No, sir.
Turn on your cameras. I need to take your attendance. Okay. So today again, I will be posting assignment on our classroom. So make or respond on classroom about assignments. Okay. Those who have not responded yet or answered yet, answer those assignments. Okay. So today we stop here. We will meet tomorrow at 9 a.m.